What's up guys, Nat here, and today we'll be discussing the UV project last Monday. So let me rate this project first. I'll give this project a medium difficulty for those people who are just starting out in electronics, and an easy difficulty for everyone who already has a background. So the story of this project is that we always needed an exposure box in school. It's not because we don't have an exposure box in school, but we always tend to do our projects a day before the deadline, because we have a college saying of due tomorrow, do tomorrow. So the UV LED circuit is not that hard to do. First, you would need to know the specifications of your LED, then the specifications of your power supply. And I suggest a power supply that's rated 2 amperes so that you'll have more current flowing through your LEDs if you need to expand it. To know how much LED you would need in your strip, you would need to divide the voltage of the power supply versus the voltage of the LED. And then you will get how many LEDs you could put in a single strip. And you can't go higher from this number because the power supply won't be able to supply that voltage. After that, you need to compute for the resistors of the LEDs, which is basically Ohm's law. We already know the voltage, it's 12 volts minus the number of LEDs times the voltage of the LED, divided by the current. What is the current needed for the LEDs? It's written in the specification. And then we can get the resistor, which is 90 ohms. There's really no 90 ohm resistor in the market, so we use the next best thing, which is the 100 ohms resistor. So next is the 555 timer circuit. It is configured in a monostable mode, and what this does is that the 555 timer circuit will only work once there is a trigger. So when the trigger hits, it will send a 5-volt supply to the output. But we don't need a 5-volt supply, because if it's a 5-volt supply, the buzzer will just keep on ringing while it's counting. So we need a hex inverter or a NOT gate to invert that 5 volts to a ground voltage, and when it's a ground voltage, convert it to 5 volts. So I didn't have any hex inverter in me, so we used an op-amp. We use a comparator, so when it is 5 volts it will be grounded, and when it is grounded it will be 5 volts. So how about for the components of the 555 timer circuit? We had a capacitor lying around 4.7 millifarads from our power supply circuit. So we used that and just convert it down. The formula is T equals 1.1 times R times C. So I already have the 4.7 millifarads, and I know already the time, which is 30 seconds, 1 minute, 2 minute, 3 minute, 4 minute, and 5 minute. So I can get the resistor for the monostable mode. So I'm using Electrodroid in this project because it's a good app, and we can easily use this for our project, especially for the LED circuit and the 555 timer circuit. So here's what troubleshooting we made in the circuit. First is the materials for the case. We use first a 1/4 illustration board for the casing, and it didn't really look that good. Next is the troubleshooting we did with the LED. My suggestion for you guys is solder half of the LEDs, solder it, then test it with your power supply. Then next is solder the next line, the next line, the next line, up to the last line, because it really didn't work out well for us. There were times when after we soldered, it just wouldn't work. We didn't know where the problem lies, because we soldered half, then we soldered the other half, and saw that it's just not working. So we need to look at all the solders. So if there's a short in the power supply, or if an LED is not working, so I suggest solder it by half, then by line, so it will not take too much time. So next problem we encountered is the power supply. So the power supply was really bad. It was a cheap power supply, and it's rated 12 volts, but when there's a load, goes down to 9 volts, and it was really frustrating because all the calculations we've done are it's all for nothing because of this power supply. So that's why we bought a not cheap power supply. It's 12 volts 2 amps. So anyways guys, that's the end of this video. If you stayed up too long, you are awesome, and if you have any suggestion for the video, go ahead and comment down below, or if you need any help, and like and subscribe. Bye.